Number 2 here, you have to recognise what kind of shape, what function. It's a parabola, and it's actually factorised into a perfect square here. So therefore I know that it shifts 1 to the right and up 2. 1 to the right, up 2. So that's the first point I'll actually put in. 1 to the right, up 2. That's the turning point. Up 2, 1 to the right. The next thing I'll do is find out where it cuts the x-intercepts. To do that, you make y equals to 0 and solve basically. And there should be 2 solutions. Can you see that if I shift the 2 across, you get minus 2 equals 2 bracket x minus 1 squared, and then if I shift the 2 across, 2 divided by 2 is minus 1. Now I'm in trouble, aren't I? Because you can't take the square root of a negative. Just pause there. So I've actually got to a point where I can't take the square root of a negative. You know that, don't you? You can't take the square root of a negative. So what do? You could actually at this point use technology to solve this. You would have to expand all this, regroup it, and use technology to solve. I'm not going to do that because I'm not using technology. On my exam I might just put some lines through it, or I could just leave it blank. What I would do, and this applies to any graph, any function, you can actually go old school, and it's not even old school, it's just using your brain, and actually choose some values of x and find the corresponding y values. If you fall flat in the exam, this is what you do. You know that at x equal to 1, y equals 2. That was the first point that I put on. So that's actually where the turning point is. I actually also think it might be a positive parabola because I can't see any negative in front of the 2 or in front of the x. So what I'm going to do is I'm going to choose some other values of x. In fact, I'll choose one either side of the turning point, 0 and 2. And I'll find the corresponding y values. Put 0 in here. 0 minus 1 is minus 1 squared. That's 1. 1 times 2, that's 2. 2 plus 2 is 4. So when x is 0, y is 4. The next one I'll do is, what did I say? 2. 2 minus 1, that's 1. 1 squared is 1. 1 times 1 times 2 is 2. 2 plus 2 is 4. Interesting. So it's actually a perfect, notice that it's going to be perfectly symmetrical. So at 0, positive 4. At 2, positive 4. Okay, I'm almost done. I might like to choose 2 more values, probably 3. And now I'm getting clever. I know that at negative 1, the answer will be the same as when it's at 3 because of symmetry. So I'll choose 1 more, choose 3. 3 minus 1 is 2. 2 squared is 4. 4 times 2 is 8. 8 plus 2 is 10. So it's off the page, but at 3 it goes to 10. So it's quite a narrow graph. So 10 is way up there. And that's that problem there done without technology. This is a really good fallback if you ever get stuck. Technically we're actually using this method for finding the x-intercepts. To find the y-intercept we make x0. To find the x-intercepts we make y0. So this is the same concept, just plotting points.